Welcome everyone. Today we are going to explore the Friedman test, a powerful non-parametric statistical tool used when our data doesn't meet the strict assumptions of traditional ANOVA testing. If you are testing a single group of subjects multiple times, such as under 3 different conditions, and your data isn't normally distributed, the Friedman test is your go-to method. It relies on the ranks of the data, rather than the raw values. Before applying the test, we must ensure our study design fits. We need a single group of subjects measured across multiple conditions. The beauty of this test is its flexibility. It does not assume that our data follows a normal distribution. Like all hypothesis tests, we start with a baseline assumption. Our null hypothesis assumes that all treatments have the exact same effect. Our alternate hypothesis states that at least 2 treatments are genuinely different. While software usually calculates the test statistic for us, it's important to understand the engine under the hood. The formula scales the squared sum of the ranks by the number of participants and conditions. To make a decision, we can use 2 approaches: comparing the calculated f sub r value to the critical chi-square value, or comparing the p-value to our alpha level. If f sub r is greater than the critical value, or the p-value is less than or equal to alpha, we reject the null hypothesis. Rejecting the null hypothesis tells us there is a difference, but not which specific pairs differ. We need to conduct post hoc tests, like the Wilcoxon signed rank test, and apply a Bonferroni correction to control for type 1 errors. Let's use a practical example, testing 3 drugs on 7 people. We define our hypotheses, set alpha at 0.05, calculate the degrees of freedom as 2, and find the critical chi-square value of 5.991. After ranking the reaction times and summing the ranks for each drug, we calculate the f sub r value, which is 8.857. Since 8.857 is greater than the critical value of 5.991, we reject the null hypothesis. There is a significant difference. Thank you for joining this educational video. If you found this information helpful, please consider liking and subscribing to stay updated on modern experimental design and advanced statistics.